day. Okay, what do we got? I figured. That way you get a good sling on the level 1. Of course, there's a snake right there. Why wouldn't there be a snake right there? Yeah. Easy peasy. Javelin. Yep. Gotta love the early game. Those of you that are doing roguelikes, if you're in the stream already, there are so many good quality of life improvements this game has done right. So many annoying things it doesn't do right. Alright. Come on. As bad of a habit as Auto Explorer is, it's so nice to not have to manually type in which direction I want to go. Sure. those are. Okay. It's not good. Don't get surrounded. Bad idea. Alright. Yeah, that's helpful. Okay. Hey, 3 minutes till class. How about that? To shed. Bzz. Surprising. Yeah. Fire, because that hurts us. Cold resistance. So, should remember we have that. Hey, it's almost class time. What are you doing? Analyzing what other roguelikes do. That's clearly what we're doing here. Right. Damn. How are we all doing this morning? Now that I assume everybody has filtered into the room. Hey, hit the lair. Good time to end. Okay, we want this one, this, and this, this, and this. Couple of bugs, oh no. Such is life. Like that. Alright. Go to the lair. Generate. Drop our crap that we don't need. Like you and you and you. Okay. And let's end. Goodbye, my midnight lo-fi beats. Alright, where did we leave off? Right about here. So, welcome back, everybody. Hopefully you get your bugs worked out there. Alrighty. So, it is a very, very hazy day out there right now. So hopefully everything's going okay for you guys. These two have no relation to each other. So what we're going to talk about today is we're going to wrap up the risk and the uncertainty stuff. We'll talk about some actual project estimation. And I've got one thing at least here for you as well. I know some of you noticed this, but let me zoom in a bit. So if you go to our Blackboard page, there is a shiny new upcoming deadlines item, which should be helpful. So I was having a problem, and maybe this is something I can figure out later on. I couldn't figure out how to get it just a direct link to the assignment without having like 30 line items in here, or making another folder, which would make you click another 30 levels deep, it seemed. So I'm just going to list out the deadlines and where you can find the assignment. Hopefully that will be helpful for you. The assignments are still going to be in the same place. This is just another high-level overview for you. I have to do this manually, so if I forget to take something off, that's why. But just let me know if something is amiss. Oh, and one other thing we can do. Actually, I'm still waiting to hear back, so we'll hold off on that. I have a thought for how we can get some live chatting in with you all as well, but I still need to make sure that we are good from a privacy perspective because that's what we have to consider these days. But let's move on. So as you see here, homework is due Friday night. I've had some questions filter in already about asking for help with does this requirement make sense or. So if you have any questions, feel free to ask me before the deadline, definitely if you're unclear on something. And then after that, so I've got the 28th. This is actually the 28th and the 30th, right? Because we'll be doing this for 2 days. What I'm going to be looking for your midterm presentations. So again, I'll give you a high level of what points you have to hit, but your next assignment that you have to work on is going to basically dovetail in with it. So you're going to do basically a project breakdown, project timing, and that's going to actually inform your presentation because I'm going to ask you, well, what have you done? What do you have left to do? And hey, your next homework is what do you have done? What do you have left to do? So it should work in quite nicely, I would think. So we have that upcoming, and that is pretty much it so far. And we can move on to effort estimation unless anybody has any questions at all. I don't know about all of you, I am having a really hard time waking up today. Just seems like one of those days. This is cup of coffee number 3. I think I'm drinking decaf. All right, so we ended here, right? We started talking about the cone of uncertainty. We were talking about how uncertainty is really high at the beginning of the project, right? And as you get more and more information, trickles down to a lot less uncertainty. Now the question for all of you, and again, obviously this figure here is pretty busy. We have a lot of things going on in terms of, well, here's our, come on, pointer. Here's our phases or milestones, right? Here is the relative cost estimate, honestly, and how uncertain we are about this. Assuming, let's say that we get to the accepted software stage, right? So we have basically no uncertainty. Is there anything that we may not expect at this point in the project? Right, so we've gone through our design, we've made our software, we've gone through our quality assurance procedures. Customer likes it, they accept it. Is there any uncertainty left over? Of course. Absolutely. So we are putting our software out in the real world. Now we have to deal with the real world, right? We have recalls we might have to deal with. We might have use cases we never considered that only cropped up after the customer got their hands on it. There's still uncertainty, right? And that uncertainty can impact your project costs, project efforts, right? You're going to need to bring people back in to refine whichever phase of software development we have to fix, and then go through the process again. So is uncertainty zero at this point? Absolutely not. We are a lot more certain about our product, though. If we've done our jobs right through these different phases, we should have a lot less uncertainty, but there's always going to be room for error, right? So a early question for you all then. Let's say that we are looking at this from the project manager's perspective, right? We are trying to estimate costs. We're trying to estimate effort and workload. And we could be at any phase of development here. Effort estimations, cost estimations, these things are iterated, they're refined over time. Again, you start out with a lot of uncertainty and you refine it as you go. And the question for you all is, what kind of things could cause an inaccurate estimate? So I've got a slide here for you to see what you all think on this one. But just think of some of the problems that can impact a project. And it doesn't have to be at phase one when we know nothing, right? It could be at delivery. It could be during development time. So what do you think we have going on here? Anybody have any guesses? Unclear requirements. Excuse me. Sure. So we have maybe an early attempt at requirements, right? So we have done our group session where we tried to hammer them out with our customer, or maybe we've taken use cases and tried to write requirements from them, or vice versa. We've made our use cases, we're writing our requirements from those. And we could be at the stage where they're not completely clear. So uncertainty is coming from the fact that our programmers don't know what to do because they are guessing. Sure, unclear requirements make sense. Anybody have any other guesses? I know you're not all idling in the chat there. Underestimating how much time, poor communication. Sometimes it's hard for me to tell if there's a delay with the software or if we're thinking or if we're not awake yet, because like I said, I'm not completely awake yet. Poor leadership. Okay, so definitely some good reasons here. So it is very easy to underestimate how much time something will take. If you usually have a guess for how long something will take, you probably need to at least 1.5 to double to 2 times up the amount of effort that you have, right? Because there's always going to be something that crops up. I don't know if any of you have ever had to do any kind of housework or anything like that. It's something that I have to do, but if I need to fix something, I say it's going to take me 20 minutes and then 3 hours later, I'm only halfway done. You know, with 5 trips to Home Depot or something like that. So definitely a problem. Poor leadership can also be a problem as well. You know, your manager is not setting expectations for the project or right? So leadership's definitely a problem. And then communication, also a good guess here. So somebody did not correctly communicate what they need, right? So we talked about that last time, communication problems. This can definitely impact your project. So definitely all good guesses here. I would say these are all absolutely accurate. So I have a list here for you as well that I will pop through because these are all to kind of supplement your answers there. Again, which were right on the money. So we might have change requests. So that could be one cause, right? So our users or our clients, you know, or somebody, they like what you've done, but now they want something else. And if that is possible with your contract, then you have to build that into your effort estimation, right? It's possible we overlooked something. So those of you that said poor communication or poor leadership, for instance, we may overlook some tasks which are very common, or we just forgot about them. That's going to be a cause of an inaccurate estimate. Lack of understanding in the requirements, so unclear requirements. Perfect, right? We did not get what the requirements were. We may not have analyzed things correctly. So this is what we're going to talk about in the next little module here, when we start figuring out how we can actually estimate effort. But we may do a shallow analysis, for instance, or a very coarse-grained analysis where we're just kind of guessing and we don't take into account all the variables that go into a project, right? It's not just lines of code, or it's not just, 3 customer meetings and we're done kind of a thing. So there's a lot of variables that go into this kind of a thing. Lack of coordination. So this could go to your point about communication, honestly, right? So communication could mean many things. It might not just be client to manager to developer. We also might have problems with our technical services, right? So if we have systems administrators or data administrators or basically anybody in the chain of a project, there might be some kind of a coordination issue which sets things back. Might not be an engineer, might be a facilities issue, right? We don't have the necessary tools or machinery or space to carry out the project. So coordination definitely would be one of them too. We might not have good guidelines for estimating, so we don't necessarily know how to estimate. Basically, you all kind of nailed it, honestly. There are a lot of reasons why we could have inaccurate estimates, and it's just something to expect will happen. All right, so let's say that we are good with our estimates, right? We are going to move on now to talking about what risks we may foresee in a project. So risk is something that will happen. Generally, it's a negative consequence, right? So if I'm taking on a new project, I will try to enumerate all the risks that we foresee, right? You all did that in your proposals. What are the problems that you anticipate? And every project will have problems. Every project will have risks that you have to manage. Nailed it, absolutely. Risk is not necessarily a bad thing. Risk that is not managed is typically a bad thing, however. So again, consider that risks are basically a special category. It's not just a simple event that happens, right? Because an event is something that pops up that your system will deal with. A risk is going to have a very negative impact. All right, so let me pop through these animations here. So when we're looking at risk, we want to see 2 kind of key metrics for this. So what is the impact of this risk, right? So how much of a negative effect will it have on your project? And what's the likelihood that this event will happen? Again, it is a negative event. And you can actually take this and quantify it by multiplying these 2 together. So what's probability times the impact? And again, this is a very generic formula where impact can mean, whatever you're measuring. It could be dollars, it could be time, it could be effort. It just depends on how you're trying to factor it into your estimation here. But you basically just try to list out, hey, here's all the risks that we foresee. If you're driving a Tesla, the risk is that the person thinks the autopilot system actually means autopilot and they stop paying attention to the road, right? Well, what's the impact? Well, the car crashes, somebody dies, or you run into a building or a pedestrian. These are all very significant impacts. What's the probability this happens? If you don't train your users or communicate with them appropriately, probability is very high. If you train them well in advance, probability is a lot lower. This might not be, again, loss of life. It could be dollar amounts. You could have a conveyor belt that is being controlled by your software, and maybe you start running it too fast by accident because of some chain of events that happens. The risk is that you get into this really weird state where conveyor belts flying, products are flying off the line, and you lose a lot of money, right? What's the probability this happens? Very close to 0 because this and this and this and this and this also have to happen. But it's something that we may foresee based on how our project is configured. This is a very useful thing to go through. So it's a very useful thought experiment / piece of the effort estimation puzzle. Other thing too to consider is that risk is not a plug and play kind of a thing. right? It's not where I can sit down and calculate, okay, here is my risk category A, risk category B. This applies to every single project we have. You may have some common risks across them, which you can kind of go back to, but more often than not, they're very project specific, right? Some of you are making a roguelike game, some of you are making a calculator application, some of you are doing a phone application for calendaring. Trying to think of what else is out there. I think somebody's doing, yeah, a Unity game. Are the risks going to be the same for each of these projects? Absolutely not. So we have to basically sit and think about our project particularly. And where do we get the risks from? Well, we can look at the requirements, right? We can look at our use cases. We can look at all of our diagrams that we're creating. We can look at all of our test results and everything as we go and try to figure out what the problems are going to be. So here is a very, I'll call this an interesting chart. Basically, you don't get a lot of information out of this other than it's in your face and colorful, right? But here we have the probability that a risk will happen and its impact. So if we have a catastrophic failure, and it's got a very certain probability, we're going to have a very extreme amount of risk. Whereas if the impact is negligible, probability is rare, it's very low problem, right? Very low risk. Obviously, if you know that something's going to happen and the impact is very bad, of course you treat it like a horrible risk that you have to undertake. But just keep in mind, there's a spectrum of how these things all factor in together. And you might not have a color-coded chart for risk. These could be all hard numbers, right? Where you factor in dollar amounts and probabilities and things of that nature. This is just kind of a nice overview for your project manager or something like that. So how do we manage risk? Like I said, risk will happen, whether you want it to or not. And no matter how much you plan, something is going to come up. That's just the real world at work here. I like to go back to the fact that I really have to look this up, but I remember they found a bug with the C Hello World program that everybody learns when they first start learning C. And, you know, there's always going to be real world impact, real world risk. So things we can do, we can avoid it. We can put our head in the sand and try to ignore it. So how do we do that? Well, let's update our requirements, or let's update our system design where this risk actually will not impact us. So we can try to tweak things so that we never have to deal with this particular risk. Maybe it's something catastrophic, right? And we don't want to manage it. We do not want to deal with it. It is something outside of our system. You know, let another module handle it, let another company handle it, or however you're gonna structure that, right? So let's avoid the risk. That is definitely one possibility. We can transfer the risk. So kind of in line with avoiding, we may add a different system, right? So our particular unit, you know, let's go back to the Tesla example where our AI is, it's called autopilot, right? The risk for somebody falling asleep at the wheel is not the fault of autopilot. We may add a different system to monitor the human being in the driver's seat. So it is now this system's problem. Just kind of a ham-fisted example there, but basically the point is that one way to handle risk is to build a separate system or bring in another company to manage that risk for you, right? Maybe it's outside of the scope of your project and it impacts you, you realize it, you refine things, it is no longer your problem. So that's basically points 1 and 2. It's not our problem, it's somebody else's problem. Does that mean that we can just ignore it? Right? Let's say we discover something catastrophic is going to happen and we just change our requirements or we give it to somebody else. Ethically, that's still a problem, right? Because you have to make sure this risk is handled in some way. Not everybody's ethical though, so sometimes we just kind of put our heads in the sand. Not saying you should do that. Last but not least, let's assume the risk. So we manage the risk ourselves. We control it. What kind of insurance would cover that? Depends on the particular risk. If you're building a dam, you might have flood insurance for everybody in the nearby area, right? I do not know insurance myself other than your typical stuff, but I know that you can have catastrophe insurance. You can have, like, there's business level insurance plans which will cover you in the event of some problem happening, right? There's a lot of companies where the decision to recall comes down to how much the insurance will cover versus market loss or something like that. So it's possible that we just allow the risk to happen and then insurance will pay out for whoever is impacted. That's kind of the cold-blooded business view of it. Damn good insurance. Oh, I went to the Hoover Dam several years ago and they had so many jokes like that. Damn good insurance. This is a damned good dam. Yeah. So sorry, if we assume the risk, that means that we will structure our program. Yeah. So they're John Garrison there. Yeah. And if you haven't watched Fight Club, there's some interesting lines about that in there. But yeah, hopefully, I would agree. You start putting quantifying people as numbers in a spreadsheet, and sometimes people forget that. But yeah. Let's assume that our insurance is covering monetary loss, hopefully. But if we assume the risk, so let's say we're going to control it, we will build in features into our system to handle this risk, right? If it is something catastrophic and we know we can control it, then by all means, let's structure our program or our system to mitigate this risk. That's kind of one nice way where you can almost turn something horribly negative into something positive, right? Your system keeps people safe, prevents loss of money, prevents loss of, homes or damage or data leakage if it's a web application, right? Might not be horribly catastrophic with people's lives, could be people's privacy, people's personal information. Risk has many, many gradients of impact, right? So, some strategies for risk reduction basically transfer it or get rid of it or take it on yourself. Now, cost of reducing risk. This is one of the things we have to talk about since we're talking about cost estimation and all that. We can have a simple formula, and again, this is where we boil down people's lives or people's money or privacy or what have you into a formula, which is kind of horrible to think about. So, what's the exposure before the reduction versus the exposure after the reduction? And again, reduction here means how much risk are we exposing ourselves to before and after we've undertaken whatever activity we're using. So let's subtract out this exposure divided by the cost, and then you have a quantifiable value of risk, right? So what's basically the net benefit for undertaking one of these activities? And as painful as it is to talk about stuff like this, these are the kinds of decisions which have to be made kind of at the project management level, right? Your engineer comes to you with a problem, right? They're going through the requirements, they're starting the implementation, and they're like, hey, there is this glaring issue that we have to deal with here. What do we do? It's not the engineer's job to make that decision, right? It's higher up the chain. How risky is it to assume it versus to buy insurance versus transferring it? And this is where some of these numbers can help you make decisions. So just keep in mind, that's one of the things you may have to do if you start going to that level of engineering, I suppose. So what are some typical risks that we have? Another question for you all. I've given you a handful, right? There's lots of money, lots of life, and those are more the results of the risk. But, what are some actual risks that you may encounter? And I'm trying very hard not to sound like a heartless bastard talking about these metrics, but I will say as a as an engineer slash software developer slash project manager type of person, it's very easy to make decisions based on how you feel about something versus what the data tells you, right? And if you can point to data, you can say, this is why we made this decision versus I kind of felt like it doing it, right? Abuse of your software for negative actions. Ooh, I like that one. So you are a very altruistic person who has made this wonderful software, and then people come along and start using it to abuse others. Well, it's all to the lowest. If you aren't heartless, you'll be too expensive. Hey, you know that emote goes perfectly with that sentence too. Nice. Yep. Overloading teamwork. So yeah, it might not even be a result of our software. It could be that we're actually overloading our team. I saw an article yesterday. Let's stop glorifying CD Projekt Red for the Cyberpunk 2077 crunch that they're going through right now. Any game design team will tell you that there's always crunch time and it's expected, which is horrible. There should not be crunch time. So yeah, unrealistic deadlines, absolutely. What happens with unrealistic deadlines? You start cutting corners. You start introducing further risks, right? So this is just the start of that problem. I really like this abuse of your software for negative actions, though. I don't know how many of you have done any kind of a networking class or anything like that, or a cybersecurity class yet. But if any of you have ever used Wireshark or any of those kind of packet monitoring softwares that are out there, those kinds of things are definitely ripe for abuse. Any of you try out Wireshark yet, out of curiosity? And the reason why I ask is that I always had fun. Yeah, Wireshark is fun. Don't use it on a public network where people can tell that you're running Wireshark because they get a bit uppity about it. Reason I get a kick out of Wireshark is that the class I taught at Oakland was it was usually system administration. Um, so using something like Wireshark was second nature to a sysadmin to make sure everything on the network was legit. But the people coming out of the cybersecurity classes would tell me that we can't use Wireshark in class. It's illegal. Like, we can't do this. And I always got a kick out of that. Like, nope, it's a system administrator tool for making sure your network is doing the right thing. Problem is, people can use Wireshark to sniff personal data, right? Credit card numbers, passwords, session keys, all kinds of crazy things that are just out there on the network. Ooh, charlesproxy.com. Do I want to click this live? Web debugging proxy application. Oh, cool. Neato. That looks pretty neat. With that, I always got a kick out of showing everybody. I don't know if you've ever heard of the Black Sheep, Fire Sheep extensions for Firefox, where it was basically a Firefox extension. All you did was click a button, and it did some low-level packet sniffing on a network. It's like you could go into a Starbucks and get people's Amazon sessions, Hotmail sessions, and just hijack their data. Crazy what's out there. So yeah, overloading your team, abusing your software, lots of things that we could use. Yeah. Only reason I'm kind of hung up on this abuse type of point is that it's very easy to make software for a purpose, and then somebody's always going to find a way to use it for their own personal thing. I'll have to look into that Charles proxy thing, though. That looks kind of neat, just at a first glance. All right. So here are the top 10 risk items that we see. And this first one goes hand in hand with overloading your team. We might not have enough people or an unrealistic schedule, right? So these first two definitely go to that point. Let me just kind of pop these all up so I don't kind of go back here. Budget could be a problem as well, right? So maybe we don't have enough money to pay people, to pay license fees, so on and so forth. Again, this all goes into let's go into overload and cut corners to get the thing done. We could also develop the wrong thing, right? So maybe we create the wrong functions or we miscode our user interface. Then if somebody's reaching out to our interfaces to connect to our system, they do it incorrectly or they get the wrong data. This is actually kind of a fun little real world example. I think I brought this up before, but there was that Mars rover that crashed and burned because One team was working in metric and one was working in imperial, and they didn't realize that till the rover was crashing into the planet. So that's always a fun one. We can gold plate things. Anybody, this is kind of a fun little term where you just slap a pretty coat of paint over something awful and just call it good. There's a lot less nice ways of calling it, where you like gift wrap a nice piece of dog do from the yard, to put it nicely, I suppose. But let's make it look pretty, where there's no meat in the back end, for instance. So some basic things up here. Now we can actually start getting into the actual software engineering issues though too, right? So one of the things I mentioned earlier, where our users keep requesting new features or changes or, right? So if we have requirements that are constantly in flux, it's really hard to nail down a solid system from that because, hey, we don't know what we're doing half the time, right? We may also have shortfalls with external problems. So, right, let's get contractors, let's get modules that we're bringing in, and maybe they're not perfect for the job, or we are not getting enough, or it's not coming in on time, right? So risks could be in external factors as well. We may also have performance issues, and this could be performance in terms of the system you're developing, right? It runs too slowly, it uses too much memory, it overheats. You just throw an Electron application on an Arduino and expect it to run flawlessly or something like that, right? So all kinds of things we could deal with. And this last one's kind of a catch-all, straining computer science capability. So this is where we are saying that your team has to develop something unrealistic, for instance. So we don't have a way to do this programmatically or something of that nature. So basically, these are some of the top risks that we can foresee from a project management perspective, right? So keep these in mind as you develop your projects. Gold plating, you could almost think of developing a prototype and then releasing it as complete. I suppose would be a nice way to bring that all together. So does anybody have any questions on this stuff? So we have uncertainty, we have risk, we have kind of light project planning. Hopefully it should all make sense. A problem that I have with a lot of this kind of material is that all of it seems like it should be common sense. I know it not often is, but it's always good to have in the back of your mind that these are the problems that you will have to deal with. Alrighty. So now the last bit of project planning and management. This is where we start getting deep into pretend numbers, I suppose. So we're going to start looking at here is how do we actually estimate the cost of a project. We're going to talk about some of the different approaches and some of the different models. We're going to look at it's an empirically chosen model, so it came out of research lab basically, and it's been used. And then there's this earned value analysis thing we'll be talking about as well. So what I'm trying to get across here is that how do we actually figure out what the costs of a project will be? And again, we are still at that planning management level, right? We're still the analysts trying to figure out who we need at what point in time, how much it's going to cost the company, things of that nature, right? So how do we go through and do this? Make sure my giant mug of water is not here in the picture. Okay. How do we figure out how much something will cost? Well, the easiest way, and honestly probably the first way that a lot of people would consider, let's ask others who have done this before, right? So people maybe in your company or consultants that you bring in who have experience with a similar project. These could be, again, internal, where you already have done this project for one company, one customer, sorry, and now we're applying it to another customer. Well, a lot of the costs are probably going to be the same. They may have some tweaks for their particular program they want you to create, but as a whole, we're going to need roughly the same process, the same people. We're going to have a very similar workflow, right? So it's kind of that structured model we talked about last time. Um, so we could bring in multiple people and hopefully multiple experts, right? Not just one person, because otherwise you only get a very one-sided view here. Now, this is kind of there's a lot of these paragraphy type slides in this set. It's more for your benefit than anything. But the whole point of this is that let's bring in, say we bring in 5 people, 5 experts, right? They all give you their estimate. They're not all going to be the same, right? I look at your project, I'm going to say, oh, that's going to take you 2 months. You bring it to another professor, that should take you the entire year, or 3 months, or 5 months, right? You're going to need 10 people in your class to help work on that. And I'll say you need 2 people to work on that. And everybody's going to have their own opinion. But what you can do is if you bring in all these experts, you can kind of average what they are telling you, right? You have multiple points of data. You can try to bring them all together into one estimate. It could be that we go through different rounds of agreements where, we all get together and talk and we start refining our estimates based on domain specific things, right? We start looking at what the actual project is, we start looking at what the actual resources available are, and then we get to an estimate. This is still kind of very hand wavy, almost, right? Where it's almost an opinion style of cost estimation. But you have experts, right? And these are people who have done this before or who are trained to do cost estimation. One thing that's very helpful with this type of technique is to break down all the work packages, right? So what are the actual things that have to be done? And I've got a picture here. This is just a generic one I pulled off of Google Images. Actually, it's from Wikipedia, Wikimedia. So they're building an aircraft system here. Just kind of funny because GE is so close to us, but what do we have to do work-wise? Well, we're building an aircraft system. Okay. So this is WBS's work breakdown structure. What are the level 2 tasks, right? So again, high level, medium level, and then digging down into the actual things that we have to do. Well, we have to build an air vehicle. What does an air vehicle take up? We have to build the frame for it. We have to have a propulsion system, right? Is it a jet engine or a propeller? We're going to need various levels of software to control these things. We're going to need, navigation. If this is something for the military, there's probably going to be a weapon system on there. So basically, all of these separate work packages will be listed out, right? What are all the things that you have to do? Keep in mind, this is a very complicated system, right? It is a piece of machinery that has to fly through the air and engage with enemy fighters or, whatever the particular goal of this aircraft is. Is it only building a plane? No. There's also training. There's also data that has to be published. We may have support equipment. We're going to have facility stuff to deal with, right? We have maintenance. We have all of these things. Kind of the point I've been trying to get across this whole time is that a software project is not just writing 20 lines of Java and you're done, or 100,000 lines of Java and you're done. It's the entire ecosystem surrounding just the code. This is all part of the project. So if you get a breakdown kind of like this, then you go back and you have your expert judgment. Well, somebody who's been building, fighters for 10 years will know exactly how long it takes to put an airframe together. Or somebody who is managing the facilities for, say, training people on the ground to support the fighters and all of that, they're going to know how long it's going to take and how many people you need. So that's the whole point of having experts, is that they will approximately know how long things will take and how much it will cost, right? Because with people comes cost. So one way to do it, expert judgment. Another way, let's estimate by analogy. So I will say I was putting extra pictures in this morning to kind of jazz up the slides, and my kids got a real kick out of the stinky shoes, by the way. But we can estimate by analogy. This is, again, another kind of, let's look at what else has been done and apply our estimates to that. We may not have domain experts to come in and give us their opinion, but we might have other projects in our company that has been done. Or we may have benchmarks for competition where we know how much time and effort has gone into it. Typically in companies, looking at what other people have done is an entire aspect of the job there, right? Because let's measure how we do by other people. But we could actually look and see, hey, what else has been done? It's probably going to take us about the same amount of time. We have the same types of people, the same talent base. Um, we kind of know what has to be done here, right? So we can do it by analogy. Now, is this estimate set in stone? Same with the last one here. Is this set in stone? No. This is an estimation. This is something that you would do fairly early on so that you can get an idea of everything you're going to need for the project, right? So these will be refined as we go. Think of that cone of uncertainty model, right? Where we had something kind of going like logarithmic, right? So we had those nice reduction in uncertainty over time. The refinement, the over time, we're going to get closer and closer to the actual cost that we will have here. All right, so we have cost by expert, by analogy, and now we can talk about cost by time. So there's there's a handful of the laws that we talked about a long time ago. There was like Murphy's Law and a bunch of the other laws of what happens to projects. One of them was Parkinson's Law. And this is an interesting one that you will work for whatever time you have for the project, basically, right? So if I spec out 12 months for a project, I will have enough work to fill that 12 months. If I say the project takes 6 months, I will be able to fill that. If I say the project's going to take 6 months and then in 3 weeks I'm going to say, oh, it's actually going to take 2 years, I will have an adequate amount of work for that 2 years. So it's kind of an interesting paradox, I suppose, where no matter how much time you spec out, you'll have enough work to do during that point in time. So what this law is saying is that the cost estimation will basically depend on how much time you have. So let's say you're one of those game companies that I keep talking about. We announce at GDC that next year our product will be released. Well, we have a year to get it done. What does that mean? We have to get everything done in a year. So work will fill that time. If it is a silly little tappy mobile game, or maybe it's one of those idle types of games where things just happen, and the hard part is 2 months of coding and you still have 10 months, that 10 months is going to be filled with other software engineering activities, right? Maybe testing, market research, refinement, beta testing, so on and so forth. Point is, you're always going to have things to do. It's just where you kind of focus your efforts, I suppose. So let's say here that we have 12 months and we have 5 people. Well, we can estimate that we have 60 person months for the job to be done, right? And this will scale effectively based on how many people you have available and however many months you have. So let's say that I have 10 months of work and we estimate that maybe it's still going to take 60 person months to get the work done. Well, then we're going to need 6 people, right? So kind of the focus is how much effort there will be. Right, so we have time-based. We also have pricing-based. Let's say we're working for a customer, they give us $1 million. Whatever you get is going to go up to $1 million, and anything after that is out of scope. Make sense? So basically, we just have a dollar amount that we can work with. If we start going over budget, features are going to start getting cut because we don't have any money to pay our people or to pay for our resources, right? So if we start estimating our project and we see very quickly that we're going way out of budget, well, that's where the project ends because that's all the customer can pay for. We don't necessarily care about functionality or deliverables if it's out of scope. And kind of what we were talking about last time, where we were trying to figure out, okay, we need X people are going to cost Y dollars. We're going to need to bring in all these extra modules or pay license fees or facility charges, right? All of these things go into the budget. Once you hit that limit, That's where features end. Again, you're not making a project out of the goodness of your heart, unless you're working for a nonprofit, I suppose. But you have to be realistic with these kinds of things, right? You could liken this to your term projects, right? My available budget is your time for the semester plus the grade you want. And however much effort you put into it is going to be I guess, the time budget and the grade budget, right? A weird example, I suppose, but so we have pricing to win. We also have schedule driven. So we have a schedule of efforts to be done. So this is kind of similar to Parkinson's law, except that we now have a rigorous schedule to follow. So Parkinson's law, we basically went and said we need 1 year to get this done. And we kind of backported based on how many people we had, what the estimated effort would be, right? Here, excuse me, we have resources available to us throughout the schedule of this project. And it's very similar, but it's also distinct in that we have to kind of align the project to when these resources are available and how much of them we have at any given point in time. Slight distinction. Both are timing based in a way, but here schedule driven tends to be a little more rigorous, I suppose, in terms of what we have available to us. All right. So schedule, I kind of likened it to resources. You can also consider that the schedule is an estimate as well, right? So let's say that we have resources that we've scheduled over time, and it's possible that one of those resources becomes available sooner rather than later. You do have a little bit of flexibility with the estimate, whereas back in Parkinson's law here, we had 12 months to get something done. And we just assume the resources will be available. So it's a little bit more, I guess, brittle, or a little more rigid is the word I'm looking for. All right, so where we're going to end, and where we're going to end up talking about next time when we start talking about Kokomo, which is a interesting way to name your your estimation tool. But we can look at algorithmic costs. And algorithmic costs basically give us a model to work from. So with algorithmic, basically you write a program, or you have, some kind of a data set that you're reading from. And however you specify your model, and for a simple one, like we're going to be seeing, it's just like a handful of formulas that we plug values into. You're going to get a estimate spit out at the end. Right. Everything else so far has been kind of rule of thumb. Let's get the expert opinion. Let's look at what else has been done. That's our estimate. Here we are looking at actually trying to plug values into a bunch of formulas. Just to give you kind of a preview, so we're actually going to start looking at equations, basically. But that is it for today. So Friday we'll wrap this up. Hopefully we'll start looking at some of the tools that are available out there as well. Anybody have any questions from today? I know I had at least one group that wanted to chat during office hours about the project, so that is available as well if people are around. But other than that, I hope you have a wonderful day, and I will see you on Friday. Oh. Wave. Lovely. Need to actually look into some of these other emotes that are out there, because they're just so beautiful compared to the little robots I've got in my Streamlabs. What do we got here? Sure. Let's go with looks like a cat. I'm going to assume that's a cat. All right, bye everybody. See you next time.